In today's lecture, we are going to learn fundamental concepts of the chapter permutations and combinations. So, this chapter is very important for both mains and also advanced, and in fact, if you are aiming for computer science, then permutation, combination and probability chapters are very much alive in your future. So, from future point of view also, these two chapters are actually very important chapters. But students generally find these chapters to be bouncers. Students find them to be very lengthy or confusing chapters because students do not approach these chapters with right mindset. So, for you to gain good understanding and good problem solving skills, what is your first step? First step is to get into the basics of the chapter with right mindset. So, today what we are going to do is to build that mindset. So, today we are going to build a good mindset so that we understand the entire chapter in a much better way. So, these two chapters, permutation, combinations and also the probability, these two chapters are called as the chapters of counting. Basically, we are going to count the numbers. Okay. So, there are different styles of techniques of counting. So, we are going to learn all those techniques in a systematic manner. But remember that, let us say if I give one simple question like how many squares are there on a chessboard. So, how do you perform the calculation? Do you count the squares as 1, 2, 3, 4, 5, 6 and so on? No, there should be a pattern and you should be counting through that pattern. So, here the entire chapter is based on finding that pattern, cracking that pattern. Okay. So, as I keep saying, mathematics is full of patterns. If you crack the pattern, you have cracked the mathematics. Okay. So, before we go into the counting, let us first understand the basic fundamental theorem of counting. So, as I said, this is a chapter of counting. So, let us understand this fundamental theorem of counting. So, in general what happens is, suppose let us say there are two events A and B, and event means what? Anything that happens or occurs is an event. For example, holding a pen is an event, okay? Talking is an event, counting is an event. Okay? So, if there is an event which can occur in m ways and there is an event B which can occur in n ways. Now, either of them, what is the meaning of either of them? Either A or B. So, either of them will occur in m plus n ways. So, here what you have to understand is, what is the relation between these two events A and B? Is the relation or is the relation and? So, this is what you have to understand first, and so today we will mostly base the entire lecture on this principle only. Okay. So, here it says A or B can happen in m plus n ways. So, if there is or relation between A and B, then we have to add the total number of ways. That is what it means. So, we can also call this addition rule as OR rule. Okay. We can also call it as OR rule. So, now what is the meaning of this OR? So, let me just get more deeper into this OR. We also sometimes call this as exclusive OR. Okay. So, we also call this as exclusive OR. Now, I will explain this through this example. Let us say you are in Hyderabad and from here you want to go till Bombay. Okay. So, you want to go till Mumbai and we are looking at the modes of transport. Okay. So, let us say you have option of bus, you have option of train and you have option of flight. Okay. So, you have option of bus, train and flight. In how many ways you can travel from Hyderabad to Mumbai? So, in how many ways you can get it with the common sense only, that you might be getting that it is 3 ways. Either you go by bus or you go by train or you go by flight. Now, understand here that of course 3 is the right answer. So, understand here that if you are going by bus, you will definitely not go by train. If you are going by train, you will not go by flight. So, that means if one event is happening, the other is not happening. So, this is called as the exclusive OR. You cannot put one leg on bus and one leg on train and go. So, that means train and bus cannot happen together, they cannot happen. If bus is happening, train will not happen. If train is happening, flight will not happen. So, here there is that nature of exclusiveness. This is called as exclusiveness. Okay. So, when the relation between these three different events is exclusive OR, this is called as exclusive OR. So, whenever the relation is OR, we add the number of ways. So, bus is one way, train is one way, flight is one way. Now, because there is OR relation here, we add 1 plus 1 plus 1 and then we will get the 3 ways. So, this is a very silly and simple example, but you have to understand the concept in the right way. Okay. So, basically what is this rule? If there is OR relation, we add the total number of ways, that is it. Okay. Now, let us go to the next rule, which is also called as the AND rule. We can also call it as multiplication rule. Okay. Or we can also call this as AND rule. So, how do we understand this? If there is an event A which can happen in m ways, there is an event B which can happen in n ways, then both of them, A and B, both of them can happen in m into n ways. Now, both these events can happen together or separately, but both must happen. So, when both must happen, then the relation between them is AND relation. So, event A must happen and event B also must happen. So, that is why we multiply them. So, here this is simple thumb rule. If there is OR relation, we add them. If there is AND relation, we multiply them. Now, let us observe this in the earlier example only. Let us say from Mumbai you wanted to go till Delhi. Okay, so, from Mumbai you wanted to go till Delhi. So, now what happens between Mumbai and Delhi is, because the distance is too much, buses are not available. Okay, so, generally you do not take bus from Mumbai to Delhi. Okay. So, what are the options? You can either go by train or you can go by flight. Okay. So, here you can treat this entire process as two events. One is going from Hyderabad to Mumbai and from Mumbai to Delhi. So, your task is to go to Mumbai first and then go to Delhi. So, now in how many ways you can do that? So, here you have three different ways of performing this event, which is going from Hyderabad to Mumbai, and from Mumbai to Delhi it is two ways. So, one event has three ways, other event has two ways, but you have to perform both of them. Now, both these events cannot happen together, because you cannot go to Mumbai and at the same time you cannot go to Delhi. First you perform one event, then you perform the other event, right. So, but here both events must happen. So, now the relation is AND relation. So, we multiply the number of ways. So, if the question is in how many ways you can travel from Hyderabad to Delhi via Mumbai, so you will be saying answer to be 3 into 2, which is 6. Okay. So, now do not worry about the end answer. Here our logic is to understand why we are multiplying 3 and 2. Okay. So, now do not worry about the end result. So, in today's lecture do not worry about the numbers, worry only about the concept. Okay. So, till now we have understood what is OR rule, what is AND rule. Now, using this idea, let us enhance our understanding and solve some problems through hands on experience. Okay. So, we have understood multiplication rule. Let us say there is a problem here. So, you entered a sports shop. Okay. Now, in that shop there are 5 t-shirts kept, okay, and there are 4 different caps kept. So, there are 5 different t-shirts here, there are 4 different caps here. Now, what is the first part of the question? It says in how many ways you can buy either one of them. So, that means you can buy either one t-shirt or one cap. So, in how many ways you can buy one t-shirt? In 5 ways you can buy one t-shirt, because Here either you can buy t-shirt 1 or t-shirt 2 or t-shirt 3 and so on. So, there are 5 ways for the t-shirts. And what about the caps? You can buy either cap 1 or cap 2 or cap 3 or cap 4. So, there are 4 ways for the caps. Okay. So, now in how many ways you can buy either one of them? So, it is 5 here, it is 4 here. So, when we say either, that means either you are buying a t-shirt or you are buying a cap. So, relation is or relation. So, we add them. Okay. So, for the first part the answer is 5 plus 4. Okay. Now, for the second part, in how many ways you can buy one t-shirt and one cap? So, what is the logic here? You have to perform the t-shirt event and also you have to perform selecting a cap event. So, for this there are 5 ways, for this there are 4 ways, and you are buying one t-shirt and also one cap. So, both events must be performed. So, you have to multiply them. Okay. So, for the second part the answer is going to be 5 into 4. Okay. So, I hope you are understanding the logic here. Now, if you get micro into this 5 into 4, what does it actually mean? If you number t-shirts as T1, T2, T3, T4, T5, caps as C1, C2, C3, C4, then you have so many options here. For T1, you have C1 as option, C2, C3, C4, and again when you take T2, again you have 4 options here, C1, C2, C3, C4. Okay. So, like this, for every one t-shirt you have 4 options for the caps. So, if you count all of them, you will get 5 into 4, which is going to be 20. Okay. So, this way you can understand the micro understanding, but every time you do not need to look into the micro level. That is exactly why we are building patterns and the ideas. Okay. So, here we have understood the main idea of OR rule and AND rule through this example. Now, one more point. This chapter is actually a volatile chapter. Now, in this entire lecture or maybe in the subsequent lectures also, there is too much speaking, there is too much explaining, and there is too less writing. So, here you have to make your own notes, only then your understanding will be better. Okay. So, as teacher speaks and explains something, try to make a note of that point, so that you remember them and you can develop your own understanding. Okay. So, this chapter is very volatile. So, as soon as you watch the lecture, you have to practice some problems also. Okay. So, now let us go to another problem. There are 10 buses plying between Hyderabad and Bangalore. Okay. So, there is Hyderabad here and there is Bangalore here. There are 10 buses available. And what is asked, in how many ways can a person travel from Hyderabad to Bangalore and return by not travelling in the same bus? So, for going from Hyderabad to Bangalore, how many buses are available? 10 buses are available. So, for this journey there are total 10 ways. So, that means you can select any one bus and catch that bus. Okay. Now, the other, while returning you cannot come by the same bus, right. So, if you cannot come by the same bus, now the options that you have is only 9, while returning you have only 9 options, but while going you had 10 options. So, for return journey how many options are available? Only 9 options are available. So, return journey can happen in 9 ways. Now, in how many ways you can complete this journey? So, for going it is 10 ways, for returning it is 9 ways, and going and returning both are compulsory. So, that means relation between these two events is AND relation. So, we multiply all of them. So, here we are going to get 10 into 9. Okay. So, this way we can understand the basics of this OR rule and AND rule. Okay. So, come on, you can make a note of this OR rule and AND rule now. Okay. Now, let us take another example. Okay. So, now we are moving on to the next ideas, but we are building based on OR rule and AND rule only. Let us say you have 3 chocolates in your hand. Okay. You have 3 chocolates in your hand and there are 3 beggars there. You wanted to give 1 chocolate each to those beggars. In how many ways you can do this? So, whenever you are performing any calculation, for easy calculations, there is a standard idea of filling places. So, remember that every problem that you are solving can be equated to filling some places. So, imagine here that beggars are actually the places. This is beggar 1, this is beggar 2, this is beggar 3. Okay. So, beggars are basically some places. And when we go to the first beggar, we have 3 chocolates in our hand. So, when we go to the first beggar, we have 3 options of giving a chocolate, okay, because there are 3 here. Either he will get first chocolate or second or third. Okay. So, first beggar can get 3 chocolates. Second beggar can get 2 chocolates because 1 chocolate is already gone to the first beggar. So, now I have only 2 left in my hand. So, second beggar can get 2 chocolates. Now, what about the third one? So, when I go to the third beggar, already 2 chocolates are not there or they are already given. So, only 1 chocolate I have in my hand. So, I can give it in one way. Okay. So, now how many total number of ways? What is the total number of ways? Do we have to add them or multiply them? Now, remember both are going to give you 6 only. Either you add them or multiply them, both are going to give you 6. Answer is 6. But which is right? Multiplication or addition? Multiplication is right, because if you treat these 3 beggars as 3 events, first beggar is getting a chocolate, second one is also getting a chocolate, third is also getting a chocolate. So, that means relation between these 3 places or these 3 beggars is AND relation. So, we multiply them. Okay. So, this way we can understand the basic ideas of this OR rule and AND rule. Okay. So, now let us go to some examples. Let us build some ideas and concepts based on the fundamentals. So, till now we finished fundamentals. Now, let us build some ideas. Let us say there are 10 people, there are 4 seats available. You wanted to arrange these 10 people in those 4 seats. In how many ways you can do that? So, here we perform the calculations with respect to seats. Okay. Remember the phrases that I am using with respect to seats. So, we go to the first seat. So, here seats are the places, these are actually seats. Okay. Now, we go to the first seat and we check how many options this seat has. There are 10 people standing here. Now, first seat is now thinking which option do I have. So, first seat is actually having 10 options there, right. So, first seat can be filled in 10 ways. Now, second seat can be filled in 9 ways, because a person can sit only in 1 seat, he cannot sit in 2 seats. Okay. So, that means 1 person is already seated here. So, for the second seat it has only 9 options. So, for the second one there are only 9 options. Now, for the third one again same logic, 8 options. For the fourth one 7 options. Now, tell me, do we have to multiply them or add them? Of course, we have to multiply, because first seat is getting filled, second is also getting filled, third is also getting filled. So, the relation between these is AND rule. So, we understand this as 10 into 9 into 8 into 7. Now, do not go to NPR, NCR, we are not touching them till the end of the lecture. Okay. So, using common sense only we are trying to solve all problems here. Okay. So, now let us go to another example. These are very basic examples, but you have to understand the main logic here. Let us say there are 4 people but 10 seats. Okay. Question is about arrange 4 people in 10 seats. Now, here we will assume that people are the places, seats are the objects. Okay. So, here I will assume 4 places. Okay. Now, what are these places representing? They are actually representing people. Okay. This is the first person, this is second person, this is third person, this is fourth person. Now, when first person is thinking, he has 10 options. Okay. So, first person has 10 options. Now, that means first person will select any one seat and he will sit there. Now, how many seats are remaining? 9 seats are remaining. So, when the second person goes, second person has how many options? 9 options. Okay. Similarly, third person has how many options? 8 options. Now, fourth person has 7 options. Okay. So, the answer is going to be 10 into 9 into 8 into 7. So, if you remember now, the earlier question and this question both are having the same answer. But if you look at the calculation, earlier our calculation was with respect to seats, here the calculation is with respect to people. Okay. So, this is the phrase that you have to remember, with respect to. So, that means counting can always be switched. Okay. So, that means let us say there are objects and there are people. So, with respect to people or with respect to objects, you can switch your counting based on the situation. Okay. Now, let us see some more examples. Let us say the question is arrange 10 people in 10 seats. Now, it is same as the earlier question, right. So, here you can perform calculation with respect to people or seats, it does not matter. Okay. So, here what is the number? So, first seat has 10 options, second seat has 9 options, third seat has 8 options and so on, and the last seat will be having 1 option only. So, it is going to be 10 factorial. Okay. So, in a way we can say that these 10 factorial are called as the linear permutations. Okay. These are also called as linear permutations. That means we are basically arranging all of them in a row. Okay. So, this is like arrange, let us say the question is arrange 10 people in a row. So, what is the meaning of that? Meaning is arranging 10 people in 10 seats. Okay. Now, let us have a look at a different example. So, let us say question is how many words could be formed by rearranging the letters of the word Virat. Okay. So, I am a fan of Virat, so I will use his name. So, how many words could be formed by rearranging the letters? So, here how many number of letters should be there in the word that is required, that is not directly mentioned, but it is said that we are rearranging. So, whatever are the number of letters here should be the number of letters in the required word. Okay. So, here how many letters are there? 5 letters are there. So, imagine that there are 5 places. Okay. And in these 5 places we want to arrange all 5 letters. In how many ways we can do that? We have just learned it. 10 people 10 seats, 5 people 5 seats, 5 letters 5 places, value is going to be 5 factorial. Okay. 5 into 4 into 3 into 2 into 1, it is going to be 5 factorial here. Okay. But whenever we say word here, it need not have a meaning. If you arrange letters in a particular order, it becomes a word linguistically. Okay. So, just move on with that. Okay. Now, let us have a look at another example. So, here if you remember, we are not arranging letters in seats, right. We are not doing any seating arrangement, we are just arranging them in an order. So, that also becomes seating formation. So, seating arrangement, word formation are basically one and the same. Okay. Let us have one more such similar question. So, how many 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5, 6, 7. So, here we are forming a 3-digit number. So, what do we do? We first imagine places. What are the places here? Ones place, tens place and hundreds place, you can take them as places here. So, now our idea of places gels very much well with this number forming. Okay. Now, there are 3 places here. We want to place these digits in these 3 places. Okay. So, in how many ways we can do that? You might be thinking that it is 7 into 6 into 5, not so fast, because these are numbers. Okay. So, what happens in numbers? We can also get 2, 2, 3 as a number, 3, 3, 4 as a number, 4, 4, 4 as a number, which means digits could also repeat. But here what we did is without repeating. But if we recall our seating arrangement problem, a person can sit only in one seat, a person cannot sit in multiple seats. but a digit can go into multiple places. So, this is by common sense we have to assume that here repetition is possible. So, hence the answer should be with repetition. Okay. So, there could be two cases here. Okay. So, one is without repetition, the other could be with repetition. Okay. So, what could be the answer when we do it with repetition? It could be 7 into 7 into 7, because if I place one digit in the first place, it can also come in the second place. So, when I am moving from first place to second place, now the options are not getting reduced. So, 7 into 7 into 7 could be answer if repetition is allowed. Now, if you look at these two numbers, this number is the superset and this number is the subset. Okay. So, if you name this as, let us say, A, and if you name this as B, we can always say that A is a subset of B. Okay. So, when we count with repetition, this also counts all the numbers without repetition also. Okay. So, but in general, when you are forming a number, by default you have to assume that repetition is allowed unless it is mentioned in the question. In the question, if it is mentioned that you want without repetition, then go for this first one, otherwise this is your default answer. Okay. But here also we are basically understanding the fundamental ideas of counting only. Okay. So, we have basically understood how to arrange, how to make seating arrangement, how to shuffle or how to rearrange the letters, and how do we form a number. Okay. Now, let us have a look at a different idea of the similar situation. Let us say there are 10 people participating in a running race. In how many ways they will finish the race, assuming that there is no tie. Okay. So, there is no tie, that means two people will not tie for same position. Okay. So, that means all 10 people will have different positions. In how many ways they will finish the running race? So, here there is no seats, there is no arrangement, there are no places, but you can imagine places, because when they finish there will be positions starting from 1 to 10. So, you can imagine that there are 10 seats here and you are arranging 10 people in these 10 seats. So, in how many ways you can do that? 10 factorial ways. So, the answer to this question is going to be 10 factorial. Okay. So, if you understand the logic, probably writing the solution will take 1 or 2 lines only. That is the beauty of this chapter, but you need to understand the right approach, you need to approach with the right mindset. Okay. Now, that we have understood the basic ideas of these arrangements, let us have a look at a different kind of question. So, let us say there is a student who is attempting a paper, okay, and in that paper there are 10 questions and every question has two options, true and false. Every question has two options, true or false. Now, assuming that student is attempting all questions and also assuming that student does not know answer to any question, okay, because if student already knows the answer, he will mark the right answer, but here student is attempting all of them in a random way. So, in how many ways student can finish all attempting? So, here we have to go question by question. So, each question here becomes our place. Okay. So, here there could be how many places? 10 places. So, first place represents question number 1, second place represents question number 2, this represents question number 3 and so on till question number 10. Okay. Now, every question has two options, either true or false. So, when student is attempting, how many choice he has? He has two choice for every question. So, for every question here we will get 2 ways. Okay. So, the overall answer is going to be 2 raised to 10 ways. So, in 2 raised to 10 ways student can attempt that paper. Okay. So, till here we have basically understood the basic ideas of these counting or rule and rule. Okay. Now, let us take this to the next level. So, let us say the question is like this. Okay, so here I am not giving you much time to write, but you can probably watch video one more time and make your own notes, or you can pause the video and make notes. Okay. So, till here I have finished one phase, phase 1. So, you can make some important points. I will give you 5 to 10 seconds break, and after that again I will continue with the next phase. Okay. Okay. So, now let us move on to the next phase of these ideas. Let us say you are arranging 10 people in 10 seats, but now there is a condition. What is it? 2 people are alike. So, if 2 people are looking same, that means these 2 people must be probably twins. Okay. So, they look same to you. Okay. And in how many ways you want to arrange all of them? So, here how do we perform that? Now, remember that if there are 10 people, the maximum number of arrangements that you can get is 10 factorial. It is standard. 10 factorial is the maximum number of arrangements you can get from 10 people. Okay. So, whichever type of situation you take, 10 factorial is the maximum number of arrangements. Okay. Now, the question is this: if 2 people are alike, they are looking same to us, so what difference will it make? So, to understand this, let me take you through another example, okay, which is the next example. How many words could be formed by rearranging the letters of cool? Okay. So, here if you notice, there are 2 letters which are actually same. O and O are actually same letters. So, one letter is repeating, 2 times it is repeating. So, in how many ways you can rearrange them? This is the question. So, how do we do that? Here, if these 2 O are different, so let us name them as O1, O2. If these 2 letters are different, how many arrangements are possible? 4 factorial arrangements are possible. Okay. Now, out of these 4 factorial arrangements, there are some arrangements in which O1 is ahead of O2. There are some arrangements in which O2 is ahead of O1, right. For example, you can make lot of cases here, CO1 O2L and CO2 O1L. These 2 are ideally different arrangements. Okay. Now, again, let us say if you take this colo, okay, so CO1LO2, this is one arrangement, and CO2LO1, this is another arrangement. So, like this, for every arrangement I am getting here, I can also get its mirror image. Okay. That means, in these arrangements, O1 is coming ahead of O2, and in these arrangements, O2 is coming ahead of O1. Right. So, total, if you divide these 4 factorial into 2 groups, in one group O1 will be ahead of O2, in the other group O2 will be ahead of O1, right, and these 2 will be exactly half of. Okay. So, this group will be having exactly 12, this group also will be having exactly 12, and this 4 factorial is basically 24. Okay. But O1 and O2 are not actually same, sorry, they are not actually different. O1 and O2 are not actually different, O1 and O2 are actually same. So, that means this group and this group will be exactly same as each other, right. So, if I remove 1 and 2 letters from here, 1 and 2 numbering, if I remove that numbering, these arrangements and these arrangements will look same to you, right. So, that means there is symmetry in the arrangements. This is the buzzword. Okay. So, there is symmetry. Whenever there is symmetry, we divide with the symmetry, because here there is these 2 groups are actually symmetrical. So, now we are not actually getting 24 arrangements, we are actually getting only 12 arrangements. So, whenever there is a symmetry of this kind, we divide with the symmetry. So, here symmetry is 2 because these two groups are actually equal and they are exactly similar, exactly same, congruent, not similar. So, that means we can divide with 2 here. I hope you have understood the main logic here. Now, let us go back to the earlier question. So, here also twins are just like O1 and O2 only, right. So, what do? We divide 10 factorial with 2 factorial. Okay. So, I hope you have understood the main logic here. What is the main logic? Symmetry is the main logic. So, whenever there is a symmetry in counting, we divide with the symmetry. Okay. So, that is an important point that you should be noting. Okay. Now, let us take another example. Suppose let us say earlier we have taken the same example. So, here what I am doing is, in the beginning I have discussed some examples. Now, I am taking special variety of the same examples. Okay. For example, let us say there are 10 people participating in a running race. Okay. So, in that running race there is Indian, there is also a Pakistani, both are participating in the running race. Now, you know what we tell to our Indians, okay? Even if you lose, we do not care, but stay ahead of Pakistani, that is what we tell. Okay? So, even if you lose, we do not care, you have to stay ahead of Pakistani. So, that means here we want Indian to be always ahead of Pakistani. So, let us say if Pakistani is there in the 10th position, Indian can be in the 9th position or 8th or 7th or even in the 1st position. Now, it does not matter to us which position Indian is coming, we only want Indian to be ahead of Pakistani. So, here what exactly is the logic? Now, let us go back to the earlier example. So, here in one group O1 is ahead of O2, in the other group O2 is ahead of O1, but we want only one of them, so we divided with 2, right. It is the same logic here. Total how many possibilities are there? 10 factorial possibilities are there. Now, if we split this 10 factorial into 2 groups, in one group Indian will be ahead of Pakistani, in the other group Pakistani will be ahead of the Indian, but we do not want that group, we only want the first group. So, what we do? We divide with 2 factorial or we divide with 2. Okay. So, here you have understood another logic of division, but all 3 of them are connected. So, if 2 letters are identical, if 2 people are identical, or here you want only one order out of the 2 different orders. So, here and in the earlier examples we have understood that it is the same logic. Okay. So, this is the main point that you have to understand, that is when to divide. Okay. So, that is the main idea that you have to understand from here. Okay. So, there is a symmetry here when there were twins, so we divided. There is a symmetry here in the arrangement. So, these 2 groups are actually congruent. So, that means either you take this one or this one, it does not matter. So, there is actually overcounting here because of the symmetry. So, we divided with the symmetry. Okay. Now, the next one, we only wanted a particular order out of the 2 different orders. So, we divided with 2 here. Now, let us have a look at another example of division. Okay. So, again this is also understanding division. Okay. So, if you look at all these examples, I am basically explaining when to divide. Okay. So, understanding division, it means it is only the division. Okay. Now, let us have a look at another example. So, let us say there are 20 people in a classroom. Okay. So, and I am the teacher teaching there. So, I wanted to select 2 people from that 20 people. In how many ways I can select? So, here first person can be selected in how many ways? 20 different ways. Okay. So, first person can be selected in 20 ways. Now, after the first person is selected, second person can be selected in how many ways? 19 ways. Okay. So, first person is selected in 20 ways, second is selected in 19 ways. we have to select first person, we have to select second person also. So, we multiply them. Okay. Now, is this the right answer for the selection? Now, hold on, you have, your question is, it should be answered in the reverse way. Okay. Let us say you have A and B as the two people who got selected and they are sitting in front of you. Now, does it matter to you whether A came first or B came first? Does it matter to you? Of course not. So, that means here when we perform this 20 into 19, we are also counting the arrangements between A and B. Okay. So, this is going to include AB and also BA. That means, if first person is A, second can be B. If first person is B, second can be A. So, these two different ways are counted here. So, there is over counting here. Now, because order among A and B is not important to you, you may have to divide this with 2 factorial because order is not important to you. Okay. So, now let us counter this with another example. Okay. So, or little twisted idea of the same example. So, let us say I said there is a classroom and I am the teacher. So, I said I will select 2 people and I will treat them with paradise biryani. Let us say I say this. Okay. Now, if both persons are eating paradise biryani, now there is no difference between the first choice or the second choice, right? Both are getting the same food. So, there is no difference between the first choice and second choice. So, both choices are actually symmetric. So, we can divide with the symmetry. Now, the other way, suppose let us say if I say that the first person who is getting selected will get paradise biryani and the second person who will be getting who gets selected will get bawarchi biryani. Now, there is a difference in choice. So, here order matters. So, when order matters, we do not divide. When order is not important to us, we divide. Okay. So, this way we can understand the division when we are actually selecting. Okay. So, here now again let me recall the earlier statement that I gave. Earlier I said when there are 10 people, maximum arrangements possible are 10 factorial, remember. Now, let us say the question is somewhat like this. There are 20 people, there are 2 seats. Okay. So, 20 people and 2 seats. You want to arrange 20 people in 2 seats. In how many ways you can do that? First person it is 20 ways. For second seat we have to go by the seats. For first seat it is 20 ways. For second seat it is 19 ways. So, 20 into 19 is the number of ways of arranging 20 people in 2 seats. So, here when it comes to seating arrangement, the order A and B and the order B and A both are actually different orders because it is seating arrangement. So, as I said earlier, that kind of arrangement that we get is the maximum number that we get. So, when we do 20 into 19, what happens is arrangement AB and arrangement BA are both counted in this, but we do not want that order. So, we divide with 2 here. Okay. So, basically here we have understood when to divide and when not to divide. So, let us make some conclusions based on that. So, we divide when there is symmetry, but remember that we have to quantify that symmetry. Okay. And we divide when there is over counting. So, when there is over counting, to balance the over counting we divide. Okay. Also, we divide when internal order is not important, and we do not divide when internal order is not okay. We divide when internal order is not important, we do not divide when internal order is important. Okay. And also when a particular order is needed, then also we divide. Okay. So, these are conclusions that you should be noting. Okay. Come on, make a note of this. Okay. Now, let us take you to a little bit higher, but based on the same logic. Let us say now 10 people have to be arranged in 10 seats, but 3 people are alike. So, that means these are triplets. Okay. Triplets means all 3 look alike. So, what should be your answer? Now, maximum arrangements we will get is 10 factorial. But how many orders are possible among these 3 people? If you name them as P1, P2, P3, how many different arrangements among them are possible? 6 different arrangements are possible. So, for example, P1, P3, P2 and P2, P3, P1 and so on. So, this way we will get total 6 orders. But because this P1, P2, P3 all 3 are actually same to us. So, if I remove these numbers, it is a different, it is the same arrangement, right. All these 6 arrangements will look same to me if I just remove those numbers. So, that means there is a symmetry here. How do we quantify that symmetry? 6 is the quantification of the symmetry. So, we divide with 3 factorial. So, in a way we can say that whatever are the number of arrangements among those 3, we divide with that arrangement. Okay. Now, similarly, let us have a look at a different word forming type problem. So, here question is about in how many ways we can rearrange the letters of this word passes. So, here what happens is this letter S is repeating 3 times. So, how many total number of letters are there? Total 6 letters are there. If 3 S are written as S1, S2, S3, then the total number of arrangements are 6 factorial. But among these 3, there are 6 arrangements because these 3 can be mutually arranged in 3 factorial ways. So, out of those 6 orders, all those 6 orders will become symmetric to you. So, you divide that with 3 factorial. Okay. Now, similarly, another special variety. So, there is a running race going on. Now, there is one more fellow who is Bangladeshi. Okay. So, there is Indian, there is Pakistani and there is Bangladeshi. Okay. So, you know what we say to our Indian. Okay. Even if you lose, we do not care, you have to stay ahead of Pakistani. Now, you know what Pakistanis will say to their player? They say we cannot defeat India, but you at least defeat Bangladeshi. Okay. So, here Indian wanted to be ahead of the Pakistani and Pakistani wanted to be ahead of the Bangladeshi, right. So, out of these 3, how many arrangements are possible mutually? 3 factorial arrangements are possible. So, that is like Indian ahead, Pakistani, then Bangladeshi, or Pakistani, Indian, Bangladeshi. So, there could be 6 different arrangements. But out of these 6 different arrangements, you only want one of them. So, what do? You do 10 factorial divided by 6. Okay. So, this way we can understand the main logic of the division here. Okay. Now, let me explain this idea from using this example also. Okay. This example. So, here we wanted to form a 3-digit number. Let us say you want the digits to be in ascending order. Okay. So, now the moment I mentioned that the order should be ascending, it means numbers have to be different, right, digits have to be different, otherwise there is no ascending order. So, here it is without repetition question. So, in how many ways we can form a 3-digit number without repetition? It is 7 into 6 into 5 here, right. But hold on, here there could be any type of arrangement. So, suppose my digits are 1, 2 and 4. So, let us say these are the numbers, these are the digits which are forming the 3-digit number. How many different arrangements are possible out of these 3? 3 factorial different arrangements are possible. So, here to get an ascending order, you have to divide with 3 factorial. Because you want only one order out of the 6 available orders, you divide with 3 factorial, which is the 6. Okay. So, I hope you understood the logic of division here. Now, let us take another example of this division only. Okay. So, let us say you wanted to select 3 people from 20 people. In how many ways you can do that? So 20 into 19 into 18. This will give you selecting first person, selecting second person, selecting third person. But when you are performing the selection, order of the selection is not important to you. So whether it is ABC or BAC or CBA, it does not matter to you. So you divide with 3 factorial here to balance the overcounting, okay, because order is not important to us. To balance the overcounting, you divide with 3 factorial, okay. So this way we have understood what is symmetry in counting, what is overcounting, and what is the order being important, order not important, how do we pick a specific order. These ideas you have understood, okay. Now let me introduce you the terms of the permutations and combinations, okay. Now whatever we did here is basically NCR, okay. So this is basically 20C3, okay. So what is the meaning of this? Selecting 3 persons from 20 persons is basically NCR, which is also called as the combination, okay. So we can say that NCR is selecting R out of N. Now these could be objects, things or people or anything, okay. So NCR means selection of R from N. Now what is NPR? NPR we have understood earlier, okay. So let us have a look at these basic examples, okay. This example where we arrange 10 people in 4 seats. So 10 people in 4 seats is same as 10 PR, 10 P4, okay. So here we can simply say that NCR means arranging n people in R seats, NPR means arranging n people in R seats, NCR means selecting R out of N. This is the logical understanding of NPR and NCR. You can also derive one algebraic expression for all of them based on the understanding that we have developed till now, okay. So let us try to understand. So we define P as the permutation, C as the combination, and permutation means arrangement, combination means selection. So when we arrange n objects in n places or in a row, it is done in n factorial ways, and similarly NPR means arrangement of n people in R seats, which can be done in these ways, okay. So for example, here if you understand, this is the first seat, this is second seat, third seat, and this is the last seat. So now you can also algebraically manipulate this and convert this into this formula, okay. But understanding NPR is nothing but n people and R seats, okay. Now similarly, if let us say number of seats is high and number of people is less, then our counting will happen with respect to people, so it becomes RPN, okay. So but the idea is one and the same, okay. Now let us try to understand the idea of combinations. So combination is basically selection. So selecting R objects from n objects is called as the combination, but you have understood the main logic of the division, that is the main part, okay. And what is generally the definition of NCR? Definition of NCR is basically starting from n minus 1, take how many numbers? Take R numbers and then divide this with R factorial. So it becomes NCR, okay. So here you can also understand that the numerator is nothing but NPR and we divided that with R factorial to get NCR. So I have also proved one algebraic identity here using simple logic, okay. Now that we have understood the main idea of the NCR, we can understand a property of NCR. NCR is equal to always NC n minus R. Now what is the meaning of this? The meaning is simple. Let us say there are n people here. From these n people you wanted to select only R out of them. So in how many ways you can do that? In NCR ways you can do that. But when you are performing this selection, let us say you have separated R out of those n and separated R this side. Now how many are remaining this side? N minus R are remaining this side. So, this indirectly means that you have selected n minus r people out of the n people and kept them aside, right. So, it could also interpreted in a different way. So, which means NCR is same as NCn minus r. So, I have logically proved this also. Okay. So, now let us go to the definition of NCR in algebraic manner. So, NCR can be written as NPR by r factorial, we proved it logically. This is the formula that you can derive based on this idea, and then again this is the formula using which we have designed this idea also. Okay. So, I hope these things are clear to you. Now that we have introduced the ideas of NPR and NCR, let us solve some problems on these ideas. Okay. So, if NPR is 5040, find n and r. Now, what is the idea of NPR? N people in r seats. So, starting from n, I have to multiply all consecutive numbers, right. So, basically it is going to be n into n minus 1 into n minus 2. This will go on till a particular number, right. That becomes the NPR. So, that means we have to somehow factorize this 5040 as consecutive natural numbers. Okay. So, let me prime factorize this. So, 5040 must be now prime factorized into products. Okay. So, let me just take 10 outside. So, it becomes 504. Now, if I take 4 outside, it becomes 4 into 12 is 48 and there is 24 here. So, 126 we are getting, okay, right. And again now if I try to break this into factors. So, what are the factors that I get? So, if I take 2 out, this will be 63, which can be written as 21 into 3, right. So, we are having one 7 or 7 into 3 here. Okay. So, definitely here if you look at only the prime numbers. Okay. So, there is one 7 involved here, there is one 10 involved here, 7 is the prime number. Now, I am trying to club this into a factorization of the consecutive integers. Okay. So, here we have one 3 extra and 3, so that will give me 9. So, there is one 2 here, 2 into 4 is 8. So, luckily I got all consecutive numbers. So, using simple manipulation, I could get 10 into 9 into 8 into 7. So, which is same as 10p4. So, n is 10 and r is 4. Okay. So, this way we can solve for n and r using the basic idea of NPR. Now, similarly you can also get NCR. Okay. So, if NCR is 495, find n and r. So, your answer should be n should be 12 and r should be 4. You try to solve this as part of your homework. Okay. Now, let us solve some more problems. Okay. So, let us say there is a question here. Prove that NPR plus r into NPR minus 1 is equal to n plus 1 PR. Now, one idea could be you can use the algebra here, right. So, there is a formula for NPR, you can use the formula and try to solve it, but I will prove this using simple logic. Let us say there are n people and there are r seats. Okay. So, here so let me take n plus 1 people and let us take r seats. Okay. So, n plus 1 people are there and there are r seats. Okay. So, here if you take any one seat or something, okay. So, or let me just do it in a different way. Okay. So, let us say there are n plus 1 seats and there are r people. Okay. So, let me explain it this way. Okay. Now, in how many ways you can arrange them? In n plus 1 PR ways you can arrange them. Okay. So, this we have understood as part of our earlier understanding. Now, let me explain it using a different idea. So, let me take the first seat. Okay. Now, when I am looking at the first seat, it can be either empty or it can be filled. It can be either empty or it can be filled. Okay. So, let us take these two cases. One is seat 1 is empty. if seat 1 is empty, then how many seats are remaining? N seats are remaining. Out of these N seats only R people will sit, right. So, that counting will be NPR, right. Now, let us say first seat is not empty, that means seat 1 is already filled. Okay. So, first seat generally can be filled in how many ways? How many options are there? R options are there. So, first seat can be filled in R ways. So, now we are assuming that first seat is already filled. So, how many seats are remaining? N seats are remaining, but how many people are remaining? R minus 1 people are remaining. So, in how many ways you can arrange N people in R minus 1 seats? In NPR minus 1, right. So, out of these total arrangements, first seat can be either empty or it can be filled. So, if you add these two cases, this must be equal to this number, right. So, logically we have proved this problem. Okay. So, this way we can understand the main logic of NPR and NCR, and also we can solve algebraic identities, we can prove them using basic logic also. Okay. So, with this we will close today's lecture. So, if you recall what has happened in the today's lecture, we have learned what is the fundamental theorem of counting, what is AND rule, what is OR rule, and then while going through the process we have understood when to divide, when not to divide, and based on these ideas we have designed NPR and NCR. Okay. So, I have not gone much into algebra, but I have gone completely into conceptual understanding. I hope you have liked the lecture. We will meet again in the next lecture with more interesting presentations like that. Until then, have a great learning day. Learning shall never stop.